Hi, Math 2. Let's take a look at completing the square using a generic rectangle. Now, as we've talked about, we've learned how to solve quadratic equations, but so far only using zero product property. Sometimes we run into an equation like x squared minus 6x minus 1, and we say, can I write this as a zero product property in factored form? But this does not factor. So since this will not factor, I need to find another way to solve this equation. The first thing I'm going to do is I'm going to always take my constant term c and move that over to the right-hand side of the equation. So in this instance, I'm going to add 1 to both the left and to the right and end up with x squared minus 6x equals 1. Now I'm going to tell you my goal is to take the left-hand side of this equation and rewrite it as sum parentheses squared. Now to do that, I'm going to detour for a moment and look at this box on the left. And I'm drawing a square. Now when I talk about squares, squares have 4 sides that are exactly the same. So I know that when I fill in my missing dimensions along the top of the square, they need to be the same as the dimensions to the left. I'm going to start this out very similar to a factoring problem, in that my x squared term is going to go into the top left. Now I know that my negative 6x needs to be split between these two diagonal boxes on the bottom left and the top right. But since it's a square, I need that negative 6x split evenly. So negative 6x divided by 2 equals negative 3x. So I'm going to put negative 3x in both the top right and the bottom left box. Now I don't know the value that goes into the bottom right box. I don't know my constant number that needs to be added. But I'm going to start looking at the box and see if I can find some missing dimensions. Well, I know that x times x gives me x squared, and x times negative 3 gives me negative 3x. X times negative 3 also gives me 3x, which means I can now find that missing value in my bottom right corner. That's going to be 9. So this box now represents x squared minus 6x plus 9, which can also be written as x squared minus 6x plus 9 equals x minus 3 squared. And that x minus 3 squared comes from the fact that the length and the width of my square are both x minus 3. I could also think about it as x minus 3 times x minus 3, but we want to keep the shorter version to help us later on. So someone for sure right now is asking, Ms. Shana, what does this have to do with my problem? Well, I could take my x squared minus 6x and rewrite it just like this square helped me solve, as x minus 3 squared. But in order to do that, I need to add 9 to the right-hand side. But whatever I do to the right-hand side has to also happen to the left. So I'm also going to add 9 to the left. So we get x minus 3 squared equals 10. And from here, we're going to solve for x. if we have x minus 3 squared equals 10, I'm going to square root both the left and the right to get rid of the square root. So x minus 3 equals the positive or negative square root of 10. And then to solve for x, I add 3 to both the left and the right. So x equals 3 plus or minus the square root of 10. Now for part B, I'm going to follow a very similar approach. We start with the equation x squared plus 2x minus 3 equals 1. And I'm going to first move the constant of negative 3 to the right by adding 3 to both the left and the right. So we get x squared plus 2x equals 4. Now from here, I'm going to take that right-hand side, x squared minus 2x, and use it to create a square. And in my square, I'm going to have my x squared in the top left. And I'm going to take my 2x and split it in half to get 1x. So I put 1x in both the top right and the bottom left. Now, as I'm doing that, I ask myself, okay, what are going to be the dimensions of my sides? Well, x times x gives me x squared. X times positive 1 gives me 1x. X times another positive 1 gives me my other 1x. And I can solve for my missing square by saying, oh, 1 times 1 equals 1. So now that 1 that I added in my bottom right rectangle, or bottom right square, I need to add that 1 to both the left and the right of my equation, which gives me x squared plus 2x plus 1 equals 5. But based on my square at right, we know that x squared plus 2x plus 1 is really x plus 1 squared. And that equals 5. And now I need to solve for x. Take the square root of the left and the square root of the right. X plus 1 equals positive or negative square root of 5. And then I can get the x by itself by subtracting 1 from the left and the right. X equals negative 1 plus or minus the square root of 5.